Calculates math and history, and we're going to be using compound inequalities and applying them with angles. So, in this video, we're going to be using compound inequalities with two different types of angles, an acute angle and an obtuse angle. Let's start with the acute angle. And we have our example problem right here. So the main objective is to find all the numbers or values of what x is, such as this is an acute angle. This is the angle, how wide these two lines are away from each other. And our equation is 2x plus 4. Remember, an acute angle has to be greater than 0, and it also has to be less than 90 degrees, because an acute angle has to be less than 90 degrees. 90 degrees is actually a right angle.
Patrick, the lid's already off.
Oh, now it's my turn.
I'm thinking I should do this one too, Patrick.
So, since the type of angle that we're working with is an acute angle, and an acute angle is less than 90 degrees, it also happens to appear that there's an equation right here, and that's telling us that whatever this equation is how much in degrees this acute angle is. So, with that equation, 0, it has to be greater than 0, because if we do have it at 0, then it's just going to be a line. It wouldn't really be an angle, because 0 degrees is just a line, no angle. So our equation has to be greater than 0, or we don't even have an angle. But we also have to have it less than 90 degrees, because an acute angle is less than 90 degrees. If it was 90 degrees, then we would be measuring a right angle, which we don't want to do. So here's our equation. We have 0 is less than 2x plus 4, and also has to be less than 90 degrees. So what we gotta do is we gotta normally simplify this, just as if you would have 5x plus 5 equals 20. We would want to simplify that by subtracting this side by 5. So, with our equation right here, since we don't have just one of these, it appears that we have 2. So we're going to subtract this by 4 and subtract these both sides by -4. Because this acts as if it was an equal sign, and this one also acts as if it was an equal sign. So we gotta do double damage. So 0 minus 4 is -4. Rewrite the whole problem, 2x, and 90 minus 4, that is 86. So this is pretty much solving this sort of problem, but the only difference is that there are actually 2 of them. So you gotta do double damage. After that, we can divide both sides by 2 to get x alone. So these two cancel out. -4 divided by 2. If you wanted that as a number, you'll get -2 is less than x, which has to be less than 86 divided by 2 is 43. So here is our simplified equation. -2 is less than x, but x is less than 43. That's what can be used to find the angle of this acute angle. Any number that is greater than 0 and less than 90 But if we find x, any number that's greater than -2, but we don't use negatives in geometry, but less than 43 for x, will become an acute angle. So we found a solution to this one, but what happens if we use an obtuse angle? With an obtuse angle, everything is still solved normally. So this is an obtuse angle, and here is our equation that's pointing at how wide in degrees our angle is. So with an obtuse angle has to be greater than 90 degrees, but it can also be less than or equal to 180 degrees. You can actually have an obtuse angle that lies flat, but also looks like this. So pretty much is bent to the other side. Any angle can be called an obtuse angle if it lies in the range of greater than 90 degrees or greater or equal to 180 degrees. So, since we have this equation up here, we're going to insert it into here. So, 7x minus that by 1. So here is our equation. 90 has to be less than 7x minus 1, but can be less than or equal to 180 degrees. So let's start simplifying. What we can do is add by 1, and since we have two symbols that act like equal signs, what we can do is do double damage and add this by 1 and add this by 1. 90 plus 1 is 91, and 180 plus 1 is 181. So, we have a simplified equation as 91 has to be less than 7x, which can be less than or equal to 181. And to get x alone, we're going to have to divide this by 7, this by 7, and this by 7. But the problem is, how can you divide evenly by 7 with 91, and how can you divide evenly with 7 with 181? If you try and do that, you'll come out with an irrational number and will also become a decimal, which we don't want. So what we're going to do is cross out the two 7s because they cancel to get x alone. So pretty much our simplest form of this equation is going to be 91 over 7 is less than x, but is also less than or equal to 181 over 7. If you're in high school and you come across a fraction, then your teacher is going to want you to leave it as a fraction. In middle school, your teacher wants it as a decimal as 0.25 or as an improper fraction of 5 over 4. So pretty much, in middle school, they want answers that are these. But in high school, they want an answer as a fraction. That is what you get as an answer. Since we have a simplest equation right here, anything that is greater than 91 over 7 and is less than or equal to 181 over 7 will work as x. But if you take a look at the normal equation that we have right here, if you insert what you got into x, then pretty much x will tell you how many degrees this angle is right here in the obtuse angle. Now we understand how to solve compound inequalities with an acute angle and an obtuse angle. Thank you for watching How Penalized Math Industry. Like and subscribe.